or not. This I will share the slides. Okay, whether it is visible?
No, sir.
Okay, let me check.
Now visible.
Okay, okay, okay. So now if you see the slide, okay, what you are looking at the slide, it is same slide that we are using in digital communication. So now, related to the first unit of wireless communication, we are dealing with the channel. We are dealing with the channel. So if you consider from here transmitter to the receiver, there is a channel that is HC of T, channel having the impulse response HC of T, right? Now we have to discuss about how that channel behaves. So the statistical parameters or the characteristics of the channel and how to model that particular channel. Okay. So now why we have to model that particular channel? Anybody can answer this question? Why we require them to model that channel? Any guess? Why we require to model that channel? Any guess? So when we transmit a signal from transmitter and we receive the signal at the receiver, so there are two antennas, transmitter antenna and receiver antenna. The signal propagates in terms of electromagnetic waves. Okay. And when the signal travels through the air, what will happen with respect to distance? The signal may get deteriorated, okay, or the signal strength that will reduce. Same time, the signal may propagate through the different path. Just now we have discussed earlier that there are different buildings may be there, mountains may be there, obstacles may be there, and because of that the propagation of the signal all over the directions, you can say, which is get hampered, and the signal may not reach up to the antenna up to the required quantity, or we can say quantity in the sense the strength of the signal. Okay, so minimum strength of the signal required at the receiver to get the signal back or to receive the signal is the sensitivity of that particular receiver. And if the signal which is not coming to that particular strength, it is very difficult. So we have to basically model that particular channel, and based on that channel modeling, we have to find out how much is the power required for the transmission. So all these parameters that we have to discuss in unit number 1. So with respect to this diagram, what I'm mentioning here is what we have to discuss. But before starting this modeling of this particular channel, what we'll do, we'll discuss how the evolution of this wireless communication. So basic fundamentals of wireless communication system. So chapter 1, the first content, first point is overview of wireless communication system. Is it visible? Is it visible now?
Yes, sir.
Okay. So just I will go in briefly. I will go through the slides. Okay. These are very easy, very fundamental things, and what we'll discuss is the evolution of this wireless communication. So this is theoretical part. You can go through the first around 8 to 10 pages of first chapter of Andrea Goldsmith. You will get to know. So, but just I will go through that rapidly. Okay. So history of wireless communication. So pre-industrial age. So smoke signal, torch signal, flashing mirrors. So these are the basically this signaling, which are a basically we can say that wireless communication, which is pre-industrial age. Before century, we can say this start around 200 back century. We can say it is already started. Okay. But this is a visual communication to gather the people, to give some instruction to the people, or something like that. Okay. After that, Morse code that we you know at least. know in the sense the name of Morse that you know, telegraph network which is established in 1838, and later the telephone which is established, the telephone network discovered. Then 1895, first radio transmission, Marconi. So this name you should know that this is a very important scientist, you can say, the inventor who developed this first radio transmission, okay, which is around 18 miles away. So further rapid advancement in the radio technology. So this is because of we require better quality, less power, small and cheaper devices, thereby enabling public and private radio communications, television, and wireless networking. So because this is a need, so the research and development, it comes from the need of the people. Then early radio system use analog signal, but nowadays if you see the signaling is in terms of digital. And the next thing which is occur, which is a packet radio or a burst transmission. So the packet, the data which is sent in terms of packet. Then first mobile, the network based on packet radio that was established in 1971, AloaNet, which is very, very important. That is a big breakthrough in that packet radio. So you have to, you should know what is that Aloha and what actually the system is. Just go through that and you will know, come to know what exactly that system is. But we'll discuss in detail about all these systems. But before starting each and every system, we'll see the history and how the systems wireless communication get evolved. Continuing with this, this was US military that was very much interested in this AloaNet, and in 1970 to 80 Defense Advanced Research Project Agency, DARPA, this is a very important agency in US, that is those have invested significant resources to develop network using packet radio and tactical communication in the battlefield. So packet radio which is established over there. This is basically a packet radio network, also found commercial applications supporting wide area network, wireless and data services. These services was introduced in early 90s, enable wireless data access, including email, file transfer, and web browsing. Low speed, but the speed was very low. Then the services mostly disappeared in 90s, late 90s, you can say disappeared in 90s, supplemented by the wireless data capabilities of cellular telephone. So nowadays, whatever we are using, all of us, that cellular telephone, that cellular concept, okay, wireless local area network, LANs and all. So reason is why low data rate of the earlier packet radio, high cost, and application limitation. So once this is the development start, so we know that 1G, first generation, that was analog, 2G, digital, which is comes into picture, 3G, 4G. Now we are entering into the 5G. Sometimes one decade later, it may be 6G technology. Okay, but as and when the applications requirements start changing, at that time, what happens is the International Telecommunication Union, Federal Communication Commission, basically these all over the world, the bodies of the telecom unions, they decide some standards, and based on that research and development which is going on and on. And because of that, 1985 Federal Communication Commission, FCC, enable a commercial development of wireless LAN and by authorizing the public use of industrial, scientific, and medical frequency bands for wireless LAN products. So even though the spectrum, which is wide frequency spectrum, you can use that spectrum, but within a specific country or within a specific zone, you should have some license. So there is some agency and that controls the specific band of the frequencies. So I think briefly I can mention here in India also, that mobile communication that established in around 2000 and all, those auctions of what you can say spectrum auctions, and we know basically 2G scams like that, right? So that is known to us, but why that scam and all it happens? Because we have to pay for that particular spectrum. Means license, you should have license to transmit the signal, license to transmit the signal. Some experimental work and all, suppose if you are using that, that signal will not interfere with the other users. But when you want to use that for the public and all public use, then there should be some standard, and the spectrum should be allocated to the specific users or service providers, we can say. And because of that, those FCC design or authorize some bands of frequencies. So current generation wireless LANs based on mainly 802.11 standard. So again, we'll come to that point later, that why that standard is required. What is the meaning of that standard? So when, from where that IEEE comes into picture, and how that standards are very, very important for this wireless communication. Now, before this wireless, so wired Ethernet today offers a data rate more than 100 Mbps. So it may be 1000 Mbps and all something like that. So more than 100 Mbps using the wired communication, wired networks. The performance gap between wired and wireless, this is a very important statement. That performance gap between wired and wireless LAN is likely to increase over the time without additional spectrum allocation. So what is the meaning? So when you say that the performance gap, what is that performance gap? So we have to go back and understand what is that performance matrix. So in digital communication, we have seen, so try to remember or keep in mind very important terms that I have mentioned every time I'm mentioning the power, every time I'm mentioning the bandwidth, every time I'm mentioning the probability of error. And one more very important parameter nowadays, very important, is latency or the delay in transmission, right? So all these parameters are very, very important. So when the dedicated wired connection is established, what happens is, if the if you are using optical fiber cable, what will happen? You can easily transfer a data rate in tera hertz and all that range, right? So this is definitely possible, dedicated. But when it comes to the wireless, definitely the wireless channel characteristics, wireless channel properties, which are very, very important, and that limits the data rate, so to improve that data rate, we have to investigate, or there should be some research and all, and that is going on. And nowadays we can have some devices, and we can get a data rate which is very, very high. So at this point, I want to mention one very important thing, that whenever we are going for, say, high data rate applications, not only the communication, but at the research or the development at the device level, which is very important. It's not just programming and writing the protocols and communication that will take place, but at the same time physical layer. Suppose if you consider the router, there is a suppose wireless router is there, then definitely that is actually hardware, whether that hardware is supporting for that high data rate. So those devices inside that particular hardware, that is also responsible for that particular speed that we are getting. So it is very important that such devices and all, there should be some development, and it should provide that much data rate. At the same time, what happens is, many times it's not only the wireless, but sometimes it is wireless to wired to wireless connection in between. So how this particular connection in between hampers that particular speed, that is also very important. We have to look into that particular aspect. So despite this data rate differences, even though wireless, we are saying that wireless is a little bit less data rate as compared to the wired communication, but still, why we are preferring that? We are preferring because of convenience and freedom of wires, because the medium is free. So it is very easy. You can take a laptop any place, and you can start communicating, right? Start communicating if you have a wireless connection which is established over there. No need for the wire. That is very, very important, even though the data rates are limited. So still further improvements in the technology which is going on, and still we can offer higher and higher data rates in the coming years. So that is very important. So most wireless LAN support applications such as email, web browsing, that are not bandwidth intensive, but gaming and all such applications, or some live, some transmission, video transmission, definitely the bandwidth requirement goes on increasing. So that is very, very important in case of wireless. Now, what are the challenges? Challenges are very important over here to mention. And those challenges are to support many users simultaneously, the bandwidth intensive and delay constrained applications such as video and gaming. Range extension is also a critical goal for future wireless LAN system. Means the range extension, how much area that you can cover, what is the bandwidth that you can provide. So all these parameters are very important in case of. So these are basically the challenges in wireless communication. The most successful application of wireless networking has been a cellular telephone. So cellular telephone, which is very important. But before that, the system began. So this system of wireless communication, when it started, basically it started in 1915, wireless voice transmission between New York and San Francisco. Further decades, so in 1946, public telephone service was introduced in 15 cities across United States. Just to take a note of this, because how the system gets evolved, the development in wireless communication. So initial systems use a central transmitter to cover the entire metropolitan area, and system efficiency is limited by the spectrum. Again, at that time, 1964, if you can imagine, so the development in electronics and all these industries. Okay, but still, the 25 cities in United States which are covered under this mobile telephone system. So introduction of mobile telephone services in New York, that supports around 550 users. So still, we at this point, if you compare that, it is too low. But still, at that time, support of so many users, that is also very important thing. Cellular concept by introduced by AT&T in 50s and 60s, improvement in capacity problem. Cellular system exploit frequency reuse. So this is very important keyword. So just note down frequency reuse. So what is that concept of frequency reuse? So we'll come to that point later. Uh, because the spectrum is limited, so we can use a small area in that zone. Same frequency we can use in the other zone as well. So that is the concept of frequency reuse. So just layman type language, I just explained that. So we'll come to that point later when it comes actually concept of frequency reuse. So two users can operate the same frequency at a spatially separated locations with minimum interference between them. So technically we can say it's a minimal interference with spatially separate locations. So efficient use of cellular system and can accommodate a large number of users. That is the requirement basically. Suppose if we can accommodate many number of users, definitely you can the service provider can get more profit out of that. Just a minute. Now comes that first generation cellular system, which is deployed. Just we are coming to the point where 1G, 2G, 3, 2.5G, 3G, 4G, like that. So first generation, that was analog, and that is deployed in Chicago, 1983, and it almost saturated because the requirement which is start increasing, and analog system and the bandwidth that cannot support, or the band cannot support. So FCC increased the cellular spectrum allocation around 50 to 40 to 50 megahertz range. So second generation cellular system first deployed in 1990s, and basically it was based on digital communication. So from that onwards, a digital communication which is get evolved, and now it is a tremendous scope, we can say, and applications everywhere you will find that digital communication. The shift from analog to digital was driven by the large higher capacity, improved cost, speed, and power efficiency of the digital hardware. So I think when we study the why digital communication at that time, I think you will find the advantages of digital communication system and how it is robust and cost improved, effective, speed, efficiency, all these parameters. Then second generation cellular system initially provided mainly voice services. These systems gradually evolved to support data services. We get email, internet access, short messaging, and all. So unfortunately, a great market, because the market is this all this research and development, and this development of this cellular concept. It is depend on the market. So basically, who is providing the service, he should get the profit out of that. So market is there. So potential of the cellular phone we started increasing, and the second generation cellular standard, which are used in the three different standards in US alone, and some standards in Europe, some standards in Japan. So the compatibility issues again started. Okay, so in fact, the different cities have different incompatible standards make roaming throughout the US and world using one cellular phone, that was impossible. So again, there is a need for a standardization. So when we say that why standards and all, so standardization that will provide across the globe, we can say. So you can use any phone anywhere, and the system can be used. This is very very important. So what is the vision? The supporting information exchange between the people or devices in the communication frontier, multimedia communication from anywhere in the world using small handset devices, a laptop, enable a new class of intelligent electronic devices that can interact with each other, and with internet in addition to provide connectivity between computers, phones, security, monitoring system. So these are the different visions why we are this system completely evolved, and nowadays it is very important, and it's a part and parcel of a part of everybody's life, wireless and mobile communication, and it is now penetrated in the villages, small villages as well in India. Considering the Indian scenario, last 5 to 6 years, wireless video will enable remote classroom. Now this is very important. Now this is a pandemic situation, so we are not in a class, right? And we are using remote classroom, remote training facilities, remote hospitals, maybe anywhere in the world. So you can use service at any point in any place in the world because of this virtual and video enable remote classrooms and all. So wireless sensor, this is one more important aspect of this wireless communication. And wireless sensors have an enormous range of both commercial and military application. So you will be studying wireless sensor network as another subject. Here just I want to mention technology is wireless. So commercial application including monitoring for of fire hazards, then hazardous waste site, trace and strays in the buildings, bridges, carbon dioxide movement, and spread of chemicals and gases at a disaster site. So all these are the applications of wireless sensor network. But this sensor network, again, it is a wireless, which is very, very important. Please turn your microphone off, participants. So continue with that, the wireless sensors self-configure into the network to process and interpret sensor measurement and then convey this information to the centralized location. So a wired connection which is not required, the sensor network itself capable of generate what you can say, generate or get the data, actual data, and transmit the data to the central processing or central control unit. Military application include identification of the and tracking of enemy target, detection of chemicals and biological attack, support unnamed robot vehicles, and counter terrorism. So finally, wireless networks enable distributed control system with remote devices, sensors, and actuators linked together via wireless communication channels. And that's what nowadays Internet of Things, everywhere, wireless and internet. So such networks enable automated highways, mobile robot, and easy reconfigurable industrial automation. So all this is because of this wireless and internet development. So what is exactly that wireless communication? So wireless communication include voice, internet access, web browsing, paging, short messaging, subscriber information services, file transfer, video teleconferencing, entertainment, sensing, distributed control, all these variety of applications that can be controlled, or that can be, we can use that wireless communication technology. So system includes cellular telephone system, wireless LAN, wireless wide area wireless data system, satellite system, and ad hoc wireless networks. So all these are very, very important wireless communications. So coverage region include in building, campus, city, and across the globe. So everywhere we can connect. Now connectivity is from, suppose if you have some friend in US, you can easily just dial and you can connect with him, that particular friend and all. So connectivity, which is now improved because of this all this satellite communication, wireless communication, all these technologies. Fragmentation of wireless communication application in various segments. So this is very important thing. At this point, it is very difficult to understand, but I will try to elaborate in detail about this. What is the meaning of fragmentation and all? different wireless applications have different requirements. So now on this particular slide, we are now coming to the technical issues basically. So if you read that particular slide, you will understand that. So first, I will give you some, say, 1 or 2 minutes to read this slide, and then we'll discuss about this. Okay. So am I audible? Yes, you can unmute
Yes.
your microphone and just answer. Am I audible?
Yes, sir.
Okay.
Yes.
Whatever is written on the slide, now actually the technical content you can say, which is very important as far as your communication technology is concerned. Okay. So just I will just mention here that I want to mention that you just go through the slide, read it, and we'll discuss in a minute. So one minute I will give you to read that slide. Also, at the same time, you can enter your attendance in the chat box, your GR number and name. That's all. Okay. So anybody can anyone try to just brief about what exactly which is written on the slide? Any what you understood from this? Want to answer? Yes, Himanshu. Please unmute your microphone. Is it possible? Please unmute your microphone. So if you see this, hello, am I audible?
Yes.
Okay, if you now see uh, Prathamesh, sorry, Padmashri Shinde. Okay, go ahead. Okay, explain. Yes. Okay, if you see the what is written on that slide, voice system have relatively low data rate requirements around 20 kbps and can tolerate a fairly high probability of bit error rate, but the total delay must be less than around 30 milliseconds or it becomes noticeable to the end user. What is the meaning of this? So now if you look at this particular point, we are focusing on bandwidth, probability of error, delay, and power. So always try to understand or try to interpret or try to evaluate the performance based on these parameters. So we are evaluating the performance based on the power requirement, bandwidth requirement, probability of error, and delay requirement. So whatever I am talking on this, sometime your bandwidth may be insufficient. Okay, bandwidth may cause the problem for video. Okay, but when it is audio, if there is some error, so at some point, okay, my voice which is not proper, okay, it is breaking, but still within the context you can easily recover that data, and you can you can join in between, right? Join in between means you can find out, or you can refer, or you can easily find the meaning out of this, right? But consider that if the delay is more than 30 milliseconds, okay, so just I am talking, but the signal which is not reaching up to you, sometimes you start talking from there. So if the delay is more than 30 milliseconds, it is noticeable. So when we say that it is a voice communication, what we require is, okay, bandwidth is less, low bandwidth I can tolerate. I can tolerate probability of error, so up to certain extent, say 10 raised to minus 3 and that particular range. But if the delay is noticeable, it is annoying. Means for voice communication, what are the requirements? So these requirements are different. So we have noticed that the bandwidth, probability of error, and bit rate, these are the three important your requirements from the user point of view. On the other hand, if you consider data system, typically requires high data rate. Okay, I want to transmit a data. Okay, so I should get the data as fast as possible with a small bit error probability. So what is the data I'm transmitting? There should not be any error. So requirement is high data rate, low probability of error, okay, must be transmitted, but do not have any fixed delay requirement. So suppose whatever I'm transmitting a file, I should able to data rate should be high so that easily the file can be transferred. But if it is the file transferred correctly, if the file transfer correctly, no problem, but the delay is there, I can tolerate that delay. So requirements are different. So real-time video system have high data rate. So three applications which are given: real-time video, now high data rate requirement with the same delay constraint as voice system, while paging and short messaging have very low data rate requirement and no delay constraint. So these are the requirements from the user perspective, and all these requirements we have to satisfy within a specific what you can say wireless communication system. So we have to definitely we have to classify, differentiate, defragment all these fragment into specific categories, and then give the services. So that's why this fragmentation based on the requirement, which is very important over here. Okay. Now continuing with this points. So these diverse requirements for a different applications make it difficult to build one wireless system that can efficiently satisfy all the requirements simultaneously. So wired network typically integrate the diverse requirement of different applications using a single protocol. And this integration requires that the most stringent requirement of for all applications met simultaneously. While this may be possible on some wired network with data rates in the order of gigabits per second and bit error rate. So like suppose if I consider optical fiber cable, OFC cable, so high data rate, low probability of error. But it is not possible in case of wireless network, which have much lower data rates and high error probability, error rate. Okay, so these reasons, at least in near future, wireless system will continue to be fragmented in a different classes, you can say application, with different protocols tailored to support a requirement for different applications. So like the different protocols for specific applications that we have to use. So these are the wireless communication requirements. So computer processes voice, image, text, video data. So all these are the definitely we require to process this data. But in circuit design area required to implement the same uh, multimodalities or applications, cheap, lightweight, and handle devices that actually able to handle these devices. So whatever I mentioned, the channel is capable of transmitting, say, high data rate, but at the same time, its circuit design, hardware is again very important. So you cannot do only because you are developing some software. Your software will work for a specific hardware, so you are writing software for hardware, so definitely that is a bottleneck, you can say. So if you improve that circuit design requirements and all to support this particular applications, then only it is possible. So since consumers don't want large batteries and frequently need to recharge, transmission and signal processing in the portable terminals must consume minimal power. So like uh, consider this, your smartphones also. What we are thinking, we're thinking about the battery life, right? And the compactness of that particular device. So all these parameters we have to think about this. So signal processing required to support multimedia applications and networking functions can be power intensive, and that's why wireless infrastructure based networks such as wireless LANs and cellular system place as much of the processing burden to the fixed site. So central processing should be done so that the processing many power sensitive intensive processing can be work out over there. The associated bottlenecks and single point of failure. So if the system gets failure at a specific location or a specific point, or system particular block gets failed, definitely overall system get failure. So ad hoc wireless network without infrastructure and highly appealing for many applications due to their flexibility and robustness. So ad hoc wireless networks are very important. So these are the very important points related to this. And design of wireless networks and spectrum allocation. So all these frequency reuse, all these concepts, I think I will not go in detail about all these points, because these are the very fundamental points, and which are very easy. You can just go through that and try to get the wireless development easy. You can easily get the wireless development. So just I will skip those few slides. So I will share those slides with you. Now coming to the wireless channel. So as a signal propagates through the wireless channel, it experiences a random fluctuation. So this is where will focus in the next lecture. Okay, because in the first unit, what we have to discuss is wireless network and their capabilities. Okay, so that the random fluctuation in the time, if the transmitter, receiver, or surrounding devices you are moving, so changing the reflections and attenuation, thus the characteristics of the channel appears to change randomly with time, which makes it difficult to design a reliable system with guaranteed performance. This is one very important challenge, and that we have to basically model. So we have to model a specific channel, how to model the wireless channel. So next point of our discussion is based on modeling the wireless channel. Okay, then the important part is security is also more is also very important, more difficult to implement in wireless system, since the airwaves are susceptible to snooping, and because of that, anyone with RF antenna, they can detect. So analog cellular system, this was a drawback, no security, and which is now a digital communication. We can overcome those difficulties. So all digital cellular system implement some level of encryption. However, the enough knowledge, time, and determination uh, most of the these encryption methods can be cracked, and indeed several have been compromised. So we know that the some electronic frauds and all, because of this wireless in this wireless communication or any communication system. So security is a very important concern. Uh, I will not go in detail about this, but just I will just read out some points. Currently exists a tremendous infrastructure in the wireless wired network. So this is also very important point that I mentioned earlier, that when we develop some systems, at that time, earlier infrastructure is also very important. So suppose if I am considering that I am calling from my mobile phone to the landline, so wireless communication from where to where it will take place, but at the same time to the some wired network will be there, and we are using that infrastructure as well. So telephone system, internet and fiber optic cable which should be used. So compatibility issue is very important in this particular designing a wireless system. So interfacing between wireless and wired network with vastly different performance capabilities in a is a difficult problem. So wireless networks are mostly designed according to the layered approach. So again, we are coming to the point that layering structure and all. Okay, so the protocols, basically the protocols which are very important. So we'll study those protocols and um, how to improve the performance in this particular wireless communication application. So I will not go in detail about this, but we'll study in the unit number 5 and 6 regarding this uh, protocols and OS open system interconnection or TCP/IP model, how this layered structure which is implemented in case of wireless communication network. So now current wireless technologies which are available and which are used are cellular telephone system, then cordless phones, wireless LANs, wireless wide area wireless data services, broadband wireless access, multiple this WiMAX and all, you know that, paging system, satellite network. These are the typical wireless applications that I mentioned over here. Okay, so I think in competency and skill and competency examination, I mentioned that unit number 5 and 6. In that case, various applications which are mentioned, and you have to study, or you have to take one application, study in detail, and prepare the presentation. So just I am mentioning over here the different applications. You also go through the syllabus and find out which application that you will study in detail as the course progresses, and at the end you will prepare those presentations. Okay, now comes to the spectrum. I think I will not go again in detail about this because it's the standard values. So what I will ask you to go through the spectrum. So the frequency range over which AM radio, FM radio, broadcast TV channels, 3G, 2G technologies, personal communication services, how these spectrums are allocated by international unions and all, and how these spectrums are used in specific nation, country, we can say. And similarly, unlicensed spectrums are also available, and how the what is the use of this unlicensed spectrum also we have to understand. Okay, this is all about what you can say this the overall development in case of wireless communication system. To summarize this, what is the requirement? So again, I'm coming back to the point that the four parameters that we discussed throughout this, right from the digital communication. So requirements are power, data rate, probability of error, and delay. So we have to stick to these points, and whatever that will study in detail will be, we have to link with these four parameters. So spectrum is limited, cost is high, right? So basically auction, each country that gives a spectrum to the specific service provider with paying some fees and all. So cost is very high, and the spectrum is limited. So effectively, how we can utilize that spectrum? So modulation techniques, which modulation technique, how to utilize or utilize the available bandwidth for high data rate applications. Then channel characterization, characteristics, time varying channel, unpredictable. So how to model that channel, how to basically adapt that variations and all, so we can transmit the data reliably to the from transmitter to the receiver. So these are the challenges. So how effectively to adapt and utilize the available channel with low error probability and delay with minimum power requirements. So in one line, I can say that this is a very important challenge, and throughout this course, we have to stick to this, and we have to understand or we have to study this particular aspect, that how to effectively adapt, utilize the available channel with low error probability and delay with minimum power requirements. So this is all about this introduction to the this wireless communication and all. Okay, so now uh, what I will do, I will just ask you to, if you have any questions, or if you want to share something, you can just share that. Okay, so I unmute. You can unmute and you can share your views. Okay, in start. So this was an introductory lecture, and it is very theoretical, but very important points that we have mentioned over here are four important performance metrics and how to utilize that wireless channel, and that is a very important challenge in front of us.